No, that's not the right slide deck. I changed it. It's not MLS. It's not MLS, by the way. You can tell I copied the slides. This is DULT. I did upload new slides. Stupid. Yes, it'll all work out great. Yes. It's interesting. Why does it do that? Whatever. Not messing with it. Whatever. The new ones are up. It'll be fine. Oh, no, there they are. Oh, that's interesting. No, that's still not it. Yeah, whatever. I'll fix it. All right, let's get started. I actually did upload a new version of this that has the actual right working group name on the front of the list, but this is the DULT working group, not the MLS working group. So hopefully you're in the right spot. Apologies, last minute slide engineering sometimes causes a problem. Hi, I'm Sean Turner. Our other chair, Erica, do you want to say something?
Hi, everyone. I'm here remote.
Obviously remote. So it's the beginning of the week. This is the Note Well. This is the policies and procedures for operating in the IETF. It's a lot about like IPR policies. So if you know something about it, you got to say something about it. If I know something about it, I'm going to report it. So you can do third-party disclosures in all 9 yards. And then a bunch of other policies about anti-harassment procedures, code of conduct, etc. Basically, let's just try to keep it professional. Just kind of want to remind everybody again that we're not here to bash products. That's kind of not the point. We're all kind of here to try to make it a little bit better. Next one is Note Really Well. This is about, trying to make sure that we have a good environment. We just kind of want to stress this point that, if you're feeling harassed or feeling unsafe in any way, we have people in place that can help with that. You can ask me, you can ask area directors, we have a buds team, a whole bunch of stuff. Meeting tips. We have a really big room with not a lot of people, but I still need you to use the in-person or the on-site meeting tool and scan this QR code, because that makes sure that we get a properly sized room so that we don't get squeezed out in a tiny little room. And the other thing is we're going to use this to moderate the queue, because we have some people that are remote. And so when you're up here, if you're presenting, you'll see there's a queue that's running through here, and I can help manage it, but it's the way you can get in and out of the line. So it's good. As I've discussed earlier with somebody, sometimes it's a little hard to do it on your phone, but it'd be great if we could get going on that. All right, so the agenda, this is the fun part. I need a scribe. I need somebody to take notes. So I would love it if someone could volunteer. I don't need word for word. What I need is, basically general topic, what we talked about, summary, and any action items that we're taking. Oh, thank you very much, sir. Awesome. And you can get to it also through I think but there's a link in the data tracker that shows you where you can get to the note-taking tool. So if you want to help, that'd be great. You can jump on there. So basically, our agenda is pretty straightforward. We're going to do a little recap, do a quick thing over the goals. I'll do that. Then we're going to go through the threat model, because, again, we have 4 documents. So we'll do document 4 first, then we'll do document 1, 2, which, as you'll note, you can time to get famous if you want to write this, and 3, and then we'll do a discussion and wrap up. So unless there's anything else that anyone wants to add to that, we can just kind of get into it. Going once, going twice. All right, let's get into it. All right, so the recap for today is, again, we're in the, trying to detect unwanted location trackers. It's those little devices or little things that can get dropped in your purse, and somebody can track you, and you might not want to be tracked, and you want to know if you're being tracked. So that's really it. Where we're at the point now where we have a working group. the idea is that we have individual drafts, and after we review them and make sure that they are in good enough shape, they don't need to be completely finished, then we can adopt them as a working group, and then we can get to work on actually getting the standards done. So that's kind of the big process. The goal for today is to review whatever drafts we have and see if they're in a good enough shape as a starting point, and then we can do a working group call for adoption, which will last about 2 weeks. I might start it later in August, because I know like Europe doesn't work in August. So we can get input from everyone, and then see if the documents can be adopted, and then we'll just move on out. We have a GitHub repo that we set up. You'll note there's not a lot in there right now. It's just working group materials where like we put the architecture that we've agreed to start discussing. When the working group drafts or the individual drafts hopefully get adopted, we'll just move the repos over. So that's why I put links up there so you can jump right into them and see what you're getting. And the nice thing about this is that we can then track everything from birth to when the standard actually gets out the door. And so I think that's really it in terms of what today's goals are. Does anybody have any questions about that? Awesome, great. So there have been 2 drafts that were pumped out, and I know that a link to the third draft was sent out. How many people have read the drafts? All right, I'm seeing like 6 or 7 hands. Erica?
Yes. Oh, sorry. I was just raising my hand that I read them.
Oh, okay, yeah.
I'm responding to your question.
There is a raise hand tool, but I think it throws you in the queue. Okay, some address, but not all of them. All right, thanks, Nick. Okay, so let's get to it. Maggie or Jesse, you guys are up. Why don't I go ahead and run the slides? Again, you can just say next. Because again, thank you for sending your slides so early. Overall threat model, there we go. Confirm your selection. It's good to see you again. So, all right, off to you.
Hello. Yeah, so Jesse and I are going to present about document 4, the overall threat model. Next slide, please. So just a review of some of the motivation. So in order for the protocol to be successful, we need to have a good understanding of the unwanted tracking threat model. So our document includes a taxonomy of unwanted tracking that Jesse made, what we think should be in and out of scope with respect to attackers and victims. And this is something we really want feedback from other people on. And then also we want a lot of feedback on the design considerations for the protocols. And we're contributing to a bunch of the different working group goals, including the threat analysis, a little bit about documentation of the current state of platforms, and then the guidance for prevented unwanted tracking. Next slide, please. So just some quick definitions that we're going to use. So we're going to talk about active scanning and passive scanning. So active scanning is when a search for location trackers is manually initiated by a user, which is different from passive scanning, where a user just is notified if a platform detects something, is following them. And then tracking tag, we're defining that as a small concealable device that broadcasts location data to other devices. Next slide, please. Okay, so I'm going to turn it over to Jesse for these next couple slides.
Hi, everybody. So the taxonomy that I created, this is inspired, as mentioned in the draft, by, among other things, the models of applied privacy paper. The taxonomy is not lifted wholesale from any of that because that particular model is meant for organizational and enterprise level considerations, but its flexibility, I think, is useful for being able to generate personas for purposes of threat modeling. And so the taxonomy in this case, we're looking at expertise level. Made this pretty simple. Someone can either be expert or non-expert. And in this case, we're talking about the abuser, the stalker, the person doing the unwanted tracking. I used the standard cybersecurity terms here of attacker and target. Proximity to victim, this is important in that this is something that tends to get neglected, I think, in current understandings in the tech industry of threats. on this particular issue is that some people in this situation live with an abuser or near an abuser and others don't. People are in different states as far as that goes. So proximity to victim, high, lives with victim or has easy physical access in some way. Medium has some access, and this includes when attacker and victim are separated but are co-parenting a child, because in the anti-domestic violence field we unfortunately see a lot of situations where abusers do use children as ways to get access to devices that will then be in physical proximity of the victim. Low would be lack of access, access to resources. So this is, what external resources can the attacker use, such as hiring a hacker, having a lot of money to spend, anything that could increase their capacity beyond what they would have with their own skill and the resources that they own. Low would be that the attacker does not have access to these resources. Next slide. And then victim taxonomy, because a victim's own resources and capabilities also affect the threat model here. So again, expertise level, this is the same as the same categories as with the attacker taxonomy. Access to resources, these are defensive resources rather than offensive resources. So for instance, does the victim have money to pay for a car mechanic who could find a device hidden in the car, potentially, or access to legal resources, access to an investigator. Low, which unfortunately is very common in my experience, is that the victim is not generally able to access these things. Access to technological safeguards. So this is how readily is the victim able to use some of the existing safeguards, such as active scanning apps that are in place. And this can be a question of, is it safe for the victim to use them? Or it can be a question of, does the victim have access to them? For instance, the victim may literally not have a cell phone to use an active scanning app with. Next slide. And so in terms of usage, so that this particular category is meant to address I think it addresses some of the more general privacy concerns about, what about the privacy of the tracking accessories owner, as well as being intended to address cases where the accessories owner or an accessories owner is actually, the survivor, the person who's being abused. So kind of the other direction from how we often talk about unwanted trackers and detecting unwanted trackers. So attacker only would be the attacker controls one or more tracking tags, but the victim does not. Victim only, victim controls one or more tracking tags, but the attacker does not. So this is when the attacker is using the victim's own tag in some way to track them. And then attacker and victim is the hybrid situation where both control one or more tracking tags. Next slide. Example scenarios. We talked through these at the last meeting. What is in the draft is pretty much taken from the slides that we showed at that meeting. You can see example scenarios in document 4 or in the previous presentation. So I see there's a question, how would a victim use a tracking tag offensively? That's not necessarily what I am referring to. What I'm thinking about here is a scenario where a victim has a tracking tag for legitimate use purposes, such as, being able to track a phone or keys in case they get lost, and the attacker has compromised the victim's tag in some way, or is using is in some way using the victim's own tag that was purchased for legitimate purposes to track them. So for scenarios, you can see them in either the internet draft or the previous presentation. Next slide. I'll turn it back over to Maggie.
Thanks, Jesse. Yeah, so Jesse and I kind of tried to brainstorm what kinds of things that we think are in scope, and some of this has already been discussed in like some of the previous internet drafts, and some of this is new stuff that we came up with, so we want people's feedback on it. So in terms of the technology, I think this is something that we've agreed on for a while. So basically any easily concealable accessory is able to broadcast its location to other consumer devices. Most of the time we're assuming this is Bluetooth. There's a little bit about NFC in one of the docs. In terms of the attacker profiles, we're assuming that any attacks that use platform native tracking applications are in scope. So basically, if you're just opening up your Find My app or equivalent on any other platform and using that, that's in scope. Attacks that include physical modification of a tracking tag, for example, trying to disable a speaker. And then non-nation state level alterations to firmware or deployment of custom devices. We weren't really sure of like a better way to phrase this, so we're definitely interested in some feedback on that. But basically the idea is, if it's a person with some basic level of expertise, but they don't necessarily have like access to Celebrate or, any of these kinds of technologies that can crack encryption, those kinds of things. We assume that some of that is in scope. So basically, like if they just deploy their own custom tag, that is considered in scope. In terms of the victim profiles, we think they should basically all be in scope. Next slide, please. In terms of what we propose is out of scope, so technologies that it's either really a big device, even if it uses Bluetooth, we consider that out of scope. App-based technologies like parental monitoring apps, so it doesn't involve some sort of location tag, we consider that to be out of scope. We consider connected cars to be out of scope, and then cloud services or social media, we also consider those to be out of scope. In terms of the attacker profiles, if someone is somehow able to crack encryption or something like that, we'd probably consider that out of scope. We'd probably also consider someone jailbreaking a victim's device to be out of scope. And for victim profiles, we should say /A for that one. Next slides, please. In terms of kind of some overall design considerations, these are intentionally pretty vague because we want them to be able to apply to all different parts of the diagram of the 10 different parts of the protocol. But so we think that it's really important that the protocol includes a variety of approaches to address different scenarios. In particular, we think it's really important that they include active and passive scanning. Right now, there's more focus on passive scanning, but we think active scanning is a big one to look to incorporate. In addition to notifications or sounds, basically for people who, especially for someone who might not have access to a device. We also think that we need to account for scenarios in which the attacker has higher expertise, proximity, or access to resources within the scope previously defined. And the same thing for scenarios in which the victim has low expertise, access to resources, and or to access to actual safeguards, again, within scope. In addition, this is something that's been talked about a bunch in the other documents, which is trying to do this all in a way that avoids privacy compromises for the tag owner when protecting against unwanted location tracking using tracking tags. Next slide, please. I think that might be the last one.
That's it.
Yep. Okay, thank you.
All right, so the way I want to frame this discussion is, have we started to think about the right things that need to go in the document? So for those who have read it, or those who have at least seen the presentation now, I would be thrilled if you could get to the microphone and tell me if you're seeing what you think you need to see.
Hi, Bob Hinded. I had one specific comment, the slide about what's not in scope. There was the one about out of scope, like people who can jailbreak. Yeah, that one. It's really easy to find. I just did it myself. You type in, you know, how to disable a speaker and an AirTag. There's like a million links to that. So it's it doesn't take a very sophisticated person to be able to figure out how to do that. So I think that should be in scope.
Yeah, just to respond to that, it is in scope. If you go to the previous slide, attacks that include physical modifications of a tracking tag. So that, I agree with you, that should be in its scope. So I think that will be covered by that one.
Agreed. And also I think that that is an important case to consider because, for instance, a victim who is deaf or hard of hearing might not be able to hear a sound anyway. And so it would be important to have some other means beyond only sound of alerting someone.
Nick?
Nick Doty, Center for Democracy and Technology. I have a couple small comments that I meant to file issues and didn't get to, but I'll do that on GitHub or the mailing list, whatever is preferred. The question I have for us today is whether we want this document, the threat document, to include like details on the attacker and victim in the case where the owner of the tracker is the victim, either because the manufacturer of the tracker like has access to the location database, or the pairing database in that section reveals some information, or law enforcement is able to get access to the location tracker database. Like, do we want to include those scenarios in this document, or is that out of scope or for a different document?
If I can respond, I think that is worth considering, especially given that unfortunately there are many cases of abuse where the abuser is in law enforcement, and this is also on one. If you scroll back to the last of the, I think it's the last of the taxonomy slides. Yeah, there we go. So this is what you're asking about is exactly why I put this piece in. And you know, if you have suggestions for rewording that to be more clear or encompassing more situations, definitely definitely file issues. But that's exactly the kind of case that this particular piece is meant to address. You see also that Christine says that when the working group was proposed, it will not define requirements for interactions between accessory manufacturers and law enforcement. Yeah, I do. Yeah, I think that there is an interesting line here because it seems like the purpose of that was that we're not trying to address like governments or nation states like tracking people. It is, though, unfortunately true that there are a lot of situations where an abuser is in law enforcement, or even where an abuser works for a company that makes the tags. I've literally seen that come up before in real life, and so I think that line is fuzzy and definitely something to consider.
Yeah, to that law enforcement point, I'm not suggesting that we add requirements for if you are a tracker manufacturer, this is how you interact with law enforcement, but that we should consider the potential threats of a compromise of one of those databases, which might be through, internal attacker or compelled access.
So Nick, just a quick question. Do you think that needs to be in the draft before it's adopted, or do you think the draft could be adopted and that could be added later if we have a kind of a verbal agreement that it gets in there? Because we're always like, in the IETF, we always like stand on this weird line like, oh, is there enough in there to adopt it or not? So I'm just curious on your opinion on this.
I am constantly confused by that question. I want us to work on this document. I will file issues and pull requests. I don't feel strongly about whether it's before or after the group adopts it.
Awesome. Thank you.
And this is Barry Liebe. That's where I was going with this. There are some things that we can discuss on the mailing list. There's nothing that is high enough priority that we need the FaceTime for it. I think this is on the right track and is a really good starting point, and I don't think we should delay in adopting it.
All right, cool. So with that, what I'll do is get a working group adoption call email sent out probably today, and people can chime in on whether they think that it should be adopted. It might be a bit of a formality because there is only one document. If there were two, then we're like picking between them, but we're not doing that here. So hopefully this will go pretty quick. But great, thanks. I don't know, does anybody else have anything that they would like to add? All right, thanks Maggie and Jesse, great. All righty. Now, make sure I put up the right ones. All right. Christine.
Okay, can everyone hear me? Can everyone see me?
Yep, we can see you
Okay.
and we can hear you.
Awesome. Yeah, thank you, Maggie and Jesse. I do think, so there were some things when working on this document and writing this document and working with Eric that I felt that I had to include just to kind of give context. And that was because in studying the existing crowdsourced finding network architectures, there were some technical scenarios that kind of popped up that led to either privacy issues or security issues. So we're going to kind of go over that in this talk as well. And I did put it in my draft. But if we think that some of the things that I bring up should be moved to Maggie and Jesse's draft and that my draft should only contain the technical architecture proposal, that's also fine. But I thought it would be helpful for the audience just to give some more context and some more background about why we're proposing the things that we proposed architecturally, if that makes sense.
Yeah, Christine, this is Sean. I'm sure that there will be moving sections in all four of these documents that happens till the bitter end. So thanks for noting them.
Okay. All right. So I will jump right into it. So reiterating the motivation, and I actually took this directly from a research paper that was just presented by Alex Heinrich from TU Darmstadt, and I thought it really made a lot of sense to include here. So there's been stalking incidents using unwanted tracking with these Bluetooth trackers, and it's been documented to have happened by intimate partners, parents, and criminals. It's been seen in many major news outlets, and in at least 3 cases, the unwanted tracking resulted in the death of the tracked victim. So that's, just reiterating why it's so important for us to address this. Oh, thanks for sharing the link, Maggie. Next slide. So this was the kind of architecture that we had talked about at IETF 119. So I wanted to include that here for posterity, but I was going to explain it in a little bit more of an easy way to understand. But there are kind of 5 components to it. So there's the accessory trackers themselves. There is a tracker network or crowdsourced tracking framework that the tracker is able to somehow be tracked by, and that's what we're going to define. And then there's devices on that network. And so there's really 3 kinds of devices. There's owner devices that can pull location from the crowdsourced tracking framework. there's non-owner devices or finder devices that are reporting the location of that accessory. And then there's also the non-owner device that's an unintentional finder. So it's somebody who maybe their personal device is for some reason lending to this unwanted tracking. So that's a fifth element. And so we talked about 10 different states and things that were in scope for the design. And so my draft is addressing 1, 2, 9, and 10. So if we go to the next slide.
Oh, and sorry, just for everyone else who might not be following along, we use these numbers to figure out how we divvied up how we divvied up each part of it, which goes into which document. So if you look on the agenda, you'll see 1,279. That's all relates to what's being done where.
And there definitely is too, like some overlap. So I'm going to go back to what this document is focusing on, and I'm going to explain exactly what 1, 2, 9, and 10 is, but there is overlap between my documents and the other documents, and especially the accessory protocol, because the accessory protocol is such a huge portion of the crowdsourced network architecture that they have to work in concert with each other in order for this to actually provide some type of location mechanism. So in the current state of unwanted tracking, there are existing products on the market. There's AirTags from Apple, Samsung Galaxy Smart Tags. There's also third-party companies. So there is Tile, which has their own tracking network. But then there's companies like Chipolo and other third parties that actually leverage Apple's Find My framework. So some of these existing crowdsourced networks, so specifically the Samsung Galaxy offline finding framework and Apple's Find My framework, allow for third-party tags to leverage that. And then, of course, there's the owner and finder devices that participate in the tracking. So those owner or finder devices do the location reporting. So for Apple, it would be any Apple iPhone device. And for the Samsung framework, it's any Samsung mobile device. Next slide. Okay, so we don't have the animations, but that's okay. That's okay. So just to kind of simplify the overall functionality, so there's some kind of accessory that I referred to in the documentation as ACC. Then there is the finder device, or FD. In all of the implementations, there's some type of crowdsourced network I'm calling CN, and has a central server. So the accessory is beaconing some type of information over Bluetooth. The accessory itself does not have GPS capability. However, it will beacon, in one implementation, it's a public key. In some implementations, it's a privacy ID. There's different things that they beacon, and then whatever that protocol has chosen to beacon is received by the finder device. The finder device takes that information that it received, and it takes its own GPS location, because it's a phone, so it has GPS capability. It will package that up in some way. In some way, some implementations it's encrypted, in some implementations it is not, and it uploads that to a central server so that it can later be queried by the owner. And so the owner is able to pull down that location information. So next slide. So just reiterating the current existing infrastructure out there. So these are those third party, or these are the existing crowdsourced finding networks that have been introduced into the public. And so unintentionally, they have facilitated the use of AirTags or Samsung smart tags or tiles or other things for stalking. So these are to my knowledge, the existing infrastructure that we have that would need to be modified, but that doesn't mean that other companies aren't also working on these existing infrastructures. Next slide. So the scope of this document is specifically enrolling in a crowdsourced network. And so I would assume that this is both for the accessory, and then also I think that it should be optional whether or not somebody's device is a finder. Currently, iPhones and Galaxy devices don't have an option to not be finders. So if you have an iPhone, your phone is unintentionally acting as a finder in this network. So this is something that is in the scope of this document. Additionally, the accessory broadcast presence, because that information is part of location reporting and location querying. So on the next slide, I break down, if we go to the next slide, so the things that were part of 1, 2, 9, and 10 is that we really have to design mechanisms to ensure that any accessories or devices that aren't correctly implementing or adhering to the protocol will be detected by the protocol and both excluded by the protocol. So this would hopefully prevent counterfeit devices from operating on the protocol. We also want a tracking accessory to identify and advertise its own presence. So that's something that is part of this protocol because we aren't trying to completely strip the accessory of its location ability. We want it to be used for tracking location, just not unwanted tracking. So next slide. Okay, Brent, that's a very interesting comment. I've not seen this, so if you have any documentation, I would love for you to share it because I was unaware that you were able to opt out of Search Party D. Okay, and then I wanted to just put the scope in this document. And I think it's maybe up for debate, but at least from what I've done in this document, I haven't defined requirements for interactions between accessory manufacturers and law enforcement. And then also we're solving the use case for small and not easily discoverable accessories. So these are things like tracking tags, like air tags. And there's these little cards that Chipolo makes that work on Find My as well. So anything that's like smaller than your phone. All right, next slide. And then I'm going through the definitions. So an accessory I refer to as ACC. This is the device that's being tracked. It's assumed to lack direct internet access and GPS, but it possesses Bluetooth Low Energy or BLE capabilities, which it uses to send advertisement messages. And then, of course, the advertisement is that data that's being beaconed from the accessory over BLE. The CN or crowdsourced network is one of those networks that I mentioned that's providing location reporting, upload and downloading services for owner devices and finder devices. We also thought that the crowdsourced network could be used for authentication of devices. The finder device is a non-owner device that contributes information about an accessory to the crowdsourced network. And then there's the owner device, which is the one that owns the accessory. And so we did want to allow for there to be multiple owners of the devices, since that's already a feature of some existing technology out there. Next slide. So in evaluating some of the existing frameworks that exist, like Samsung Galaxy's framework, Apple's framework, Tile, Chipolo, TrackR, and some other ones, we identified some issues that we think should be addressed specifically by the crowdsourced network. So the crowdsourced network is allowing everybody to anonymously upload and download reports, which means that stalkers are technically able to also anonymously upload and download reports from these trackers. And so because anti-tracking was not deployed when a lot of these frameworks were first introduced, unfortunately, we saw stalking happen back in 2021. Things have gotten better, but because stalking has already happened and it has not been fully mitigated, I think that the crowdsourced network is going to have to work in concert with the anti-tracking framework, because the anti-tracking framework is going to have to leverage the existing protections in the crowdsourced network. So currently, counterfeit devices are able to leverage some crowdsourced networks because there is an authentication of these accessory devices. So that means that you can make fake tags and leverage these existing finding networks. Some tags have beacons that are very recognizable, so that makes them trackable. As an example, one of the protocols has 1,000 privacy IDs, and so over the course of a year, it will actually end up beaconing the same ID. So because of that, that means that if somebody owns a tag, even though it's rotating an ID for privacy, it actually makes that person trackable. So that's really like what Maggie and Jesse were talking about, where we don't want somebody who legitimately owns a tag to then be tracked just by those properties of that device. Okay.
So I guess before you get off that slide, though, I think Beck asked a question about what's a crowdsourced network. It's probably something that we should define as well. So have you got a couple thoughts on that?
Yes, yeah. So a crowdsourced network is the crowdsourced location tracking network, which means that it's using existing devices in order to determine location. So, for example, with AirTags, an AirTag does not have GPS. So the way that you're able to geolocate an AirTag is that it's beaconing information constantly, and any nearby iOS devices are able to receive the public key of that AirTag, which means that the receiver device, your phone, has its own GPS. And so it's going to say to the server, hey, this is the timestamp that I saw this beacon. This is my GPS. And then it uploads it to a server. So any crowdsourced network like that is leveraging all of the devices in its network to determine location. So a crowdsourced way of determining location rather than using GPS tied to that specific component. Did that answer the question?
I think so. And we can add that as a definition in the document as well. That'll help.
Okay. And I see Corbin's article. So I do want to just clarify for this. So this is not saying that I'm opting out of being a finder. This is opting out of Find My. So there's a difference in that, because if I want to have AirTags, be able to find my phone and be able to leverage Find My for finding my stuff, then I have to have Find My on. So if I disable the Find My network, that means that my device is my Apple ID is no longer participating, so I'm no longer able to find any of my stuff, use AirTags, use Find My phone. And what I'm specifically saying is there's no way to turn off your phone as a finder. So if I have an iPhone, I'm not able to turn off and say, I don't want my phone to be reporting people's locations. So I think that this is something that people should be able to say. Like, they should be able to say, I don't want my device participating in this Find My network. If that means that you also can't find your phone, then sure. But I think that turning off all of Find My is something that you can do, but that means that you also can't use AirTags. So, all right. So to get back to this, oh, sorry. Still on that slide. Go back. Sorry.
Okay, sorry.
So some tags can be impersonated. That was also information that we found. Some crowdsourced networks were susceptible to replay attacks. Some crowdsourced networks were storing identifiable information about tag owners. So this identifiable information was, for example, those rotating privacy IDs, or storing any location information in a non-encrypted state. That's a scenario where we talked about earlier, where the server or the owner of this crowdsourced network is able to access information, and which is not preserving the privacy of the end users on the network. Some networks are also blindly trusting Finder reports, meaning that any Finder device is just anybody can just upload reports, even if it's not actually a legitimate Finder device. Maybe somebody is spoofing a particular mobile device, or they're spoofing information about the tracker. And so that's important information for us to know, because we have to make sure that the crowdsourced network is authenticating all of these interactions. So next slide. And kind of talking about what our ideal properties and features would be, this would mean we want to authenticate every step in the process. So we want to make sure that the accessory and the Finder have some type of authentication, so that the Finder is able to verify that this is an authentic accessory and not a counterfeit accessory. And maybe this would mean that there's some type of secret key sharing that occurs, so that when the Finder receives some type of advertisement, it's able to call back to the crowdsourced network server and verify that this is legitimate. The crowdsourced network should also verify that the Finder itself is authentic before accepting any uploaded location information. Something that we talked about, but we haven't found exactly what the best solution would be for this, is that there should be a tag registry, and that would help prevent counterfeit and unregistered devices from utilizing the network. We would want to have some type of tag registry that also preserves end user privacy. So we'd want to make sure that tags were registered, but then at the same time, we don't want those tags to necessarily be tied back to specific people, so that it's used against them maliciously, like if a database is compromised. So that is something that we'd have to figure out and talk about. We also want the crowdsourced network to perform authentication to make sure that only valid owners are accessing reports, and not just anybody is pulling down these location reports. That's actually been shown by some researchers. Next slide. So just continuing on ideal properties and features, nobody other than the owner of an accessory would be able to learn anything about the location of a given accessory. We want to make sure that it's possible to detect when an accessory is being used to track you. It's also, we want to make it not possible for accessories not adhering to the protocol to leverage the protocol for location tracking. And we want to make sure it's not possible for unverified accessories to use the crowdsourced network protocol. Next. So in one of the papers that we referenced, there's a paper that was introduced that talked about the ideal crowdsourced tracking network. And so I liked these ideal properties and I wanted to share them. An accessory must be able to recognize who its owner is. The crowdsourced network also should be able to recognize the owners, which means that if they recognize the owners, only the owners downloading the location reports. Owning an accessory must involve performing a physical action, and this was related to a lot of the research done in force pairing to an accessory with, or force pulling down information about an accessory, or basically they were able to spoof the fact that an accessory belonged to them and pulled down information just by stealing some private type of identifier. So by having physical proximity to a device, that actually helps prevent things like that happening. Registering as an owner and an accessory with the crowdsourced network must actually involve communicating with the accessory. The Finder device can upload the location of the accessory only if the Finder device has authenticated communication with the accessory. So this would be, we don't want counterfeit reports being uploaded by a Finder device that's actually not in proximity of an accessory. Spoofing, we'd like to make it impossible to spoof an accessory. We'd like to make it impossible to spoof a location by a Finder device. And we want to make it impossible to spoof the crowdsourced network. So these are, again, they're ideal properties. I don't know if all of these asks are possible or reasonable to expect, but I thought they were useful properties that should be shared. I'm not quite sure what this comment means. Surely the ideal crowdsourced Finder network is the empty network. So if you want to explain that a little bit more, I'll just continue on and address that later. Next slide. So in this architectural proposal, there's 5 stages that I outlined, taking into account elements from documents that tried to propose, quote, ideal crowdsourced finding networks. So this was from the blind find paper that is referenced, and the the GMCK 2021 paper, which was the ideal crowdsourced network paper that the previous slide was from. So we have 5 stages: initial pairing, an accessory setup. So the accessory has to be paired with the owner device somehow, verified as authentic with the crowdsourced network. The accessory being in nearby owner mode. So in this phase, the accessory is within Bluetooth range. So in this phase, finder devices should not be generating location reports. The accessory shall behave as defined in one of the other documents. So this is, again, making sure that walking around with an AirTag or any other type of tracker like a Samsung Smart Tag doesn't allow somebody to stalk me by me walking around with my legitimately owned device. Okay, the comment, I don't like tracking at all. Let's not have AirTags. Unfortunately, I think that the business people at Apple will probably disagree with that. So that's not an option.
Thanks for laughing. Sarcasm in here.
Okay, so then the accessory in separated or lost mode is another stage that is being defined. If the accessory is not in Bluetooth range of the owner device, the accessory must generate lost messages received by the finder. The finder device has to create a location report. So upon receiving that Bluetooth packet, it's uploading the location report to the crowdsourced network if and only if it's confirmed that it is a valid location report. So we're trying to figure out, is there a way we can confirm this by the finder? And that's that accessory finder communication. Making sure that that's authenticated. Is it possible to also authenticate the finder device and crowdsourced network communication and making sure that that's authentic? Maybe we should authenticate both somehow. And then finally, the owner device would query the crowdsourced network for the encrypted location report. Okay, next slide. So as part of this setup phase, the accessory and owning device would be paired, establishing some type of shared key that's known both to the accessory and the owning device. The rest of the protocol would proceed as follows. So the accessory is periodically sending out some type of advertisement in separated mode where it contains an ephemeral public key and then also an epic key that's valid for some specified time period. The public key and its corresponding private key are generated in a deterministic fashion. And this is so that the owner device can deterministically pull down location reports in a specific time period. So in order to report an accessory's location, a finder device will leverage the public key to encrypt it, and then it will transmit that to the central service. In order to locate an accessory, the owner will generate the private key by using that original shared key. Then when it's querying the central service, it has to know some type of secret. So whether that is information derived from the public key, such as in Apple's implementation where they're generating a hash, that information is used to authenticate and download the report, and then it will decrypt it with the private key. Next slide. So in the protocol, we talk about a lot of different properties. So there's in the Blind My paper, we talked about leveraging partial blind signatures to try to authenticate the protocol. So basically what this does is the partial blind signatures are a way for us to preserve privacy of the people on the network, but also authenticate the accessories. So only authenticated accessories can be on the network. So we agree on things like the elliptic curve group, message authentication algorithms, hash functions, etc. Next slide. So we propose that the RSA blind signature protocol would be a useful property or useful protocol for people to implement. That doesn't mean that this has to be the one that's implemented, but this was one that Eric had suggested.
Well, for others, the reason why you pick it is because it's already been vetted and published in an RFC. So we have a stable reference. There's less argument. I believe this got vetted by the CFRG. So it makes things a little easier. If we want to invent our own, we got to do that whole loop. And it's hard. And I mean, Ecker and maybe you can like figure out some cryptography, but I don't want to be the one doing that. So that's why.
Exactly. Yeah. And I'm not a cryptographer either. And even in the blind my paper that I participated on, originally we were leveraging an existing paper on blind signatures, but the primary authors, which were cryptographers, actually did some research and they found that the original paper had a mistake, and then there was a follow-on paper. So yeah, definitely, we're not designing a new cryptographic protocol. I'm kind of looking to the room for cryptographers that are aware of protocols that would be able to do some of the things that I suggested in an ideal property of this crowdsourced finding network.
And luckily we got one of those guys in line. So
Awesome.
Okay. I'll be that. I'll wear that hat. Chris Patton, Cloudflare. I just wanted to point out that I think the blind RSA has an RFC, but I think that partially blind RSA is a different protocol, and it's still going through CFRG.
Okay. All right. Okay. Again, this will take some time, so hopefully they won't take longer than us.
Yeah, and even I mean the nuance between like blind and partially blind is like we don't have to, it doesn't have to be partially blind, but that was an element that was part of preserving privacy. So that's something that we could hash out later. Next slide.
Hold on, Nick.
Okay.
Yeah, I was curious about the secret key, and I'll read more, but if you can quickly help me think through the threats. If there's a shared secret key on the accessory, does an attacker who gains physical control of the accessory have the ability to extract the secret key and then generate all of the past keys and query all of the past locations of the accessory?
Yeah, so this is a great question. It really depends on the implementation protocol. So in Apple's implementation, they actually don't store like the master key on the device. So it's not like there's some specific like master key that's stored on the device. The way that they cryptographically generate the shared secret, the accessory does not have the private keys because the accessory does not need to know those private keys. They only generate the public keys. So yeah, not storing all of the keys on the device is something that's important. So once they use like this KDF, and once they start the generation process, they don't actually like need to keep storing that shared key, I don't think. Talking about past locations is actually really important, which is why we try to talk about like having some type of time-bound parameter within the scheme. And that was because the time-bound parameter will mean that the crowdsourced network is not indefinitely storing locations. We should probably suggest some type of time-bound state, so either 7 days or 24 hours or something like that, for which a location report is stored on a network. And similarly, what we tried to suggest is that if somebody pulls an old key, they shouldn't be able to pull down a location report from a period that's not valid. So by tying the time period mechanism to the signature, you're able to prevent people from forging signatures because they have to both know the valid time period of that key, and then the time period in which that key was signed, and then it has to be valid. That key is only valid for a specified period. So I think there's some cryptographic scheme that would allow us to put some type of bounds on that, but I think that's a really great thing to bring up, because we don't want them to be able to extract secrets or generate keys based on something that they found. Something that was suggested in one of the papers that I read was that there would be some type of key like burned into the firmware of the device. So that's just like another thing that may or may not be possible depending on what the device is. Like Apple has the Secure Enclave, which has the UUID burned into the chipset, but for tags like AirTags, I don't think they're not complex enough to have like some type of firmware thing like built in. So it really just depends, and that's things that we definitely need to hash out.
And is the idea that those mitigations, either what Apple is doing or some signature protection, would be defined in this protocol?
Yeah.
Okay. Thanks.
Of course, yeah. So next slide, I'm going a little over time, so I want to just kind of speed through this. So this is.
We actually still have an hour, I believe, so don't feel free to go fast. And there's some pad at the end, so feel free to go.
Okay. All right. Yeah, I was like, I feel bad. I don't want to take everyone's time. So in the initial pairing and accessory setup, we would like for there to be some type of authentication. So the accessory before the key generation process, the owner device would be able to somehow use cryptographically generated information from the accessory to verify that this is indeed some type of authentic accessory. And so this would mean that the crowdsourced network is verifying that it's a legitimate accessory, and also making sure that it's not an accessory that's already been registered. And so an idea would be provisioning it with a unique serial number that's signed by the manufacturer, so that the crowdsourced network is able to verify the legitimacy of the device. The crowdsourced network could use some type of database of registered serial numbers to prevent multiple registrations. However, we would also want to make sure that even though a device being registered with the network is understanding, yes, this is a legitimate registered device, we also don't want the network to store any private information besides that a device with this serial number was registered and that serial number is now in use. But we would want to make sure that it's not causing the end user to have private information about themselves disclosed in some way. Next slide. So this gets into the key generation and signing with partially blind signatures. So the accessory must periodically be provisioned with temporal keys that the finder devices can use to encrypt its location reports. So this would mean that there's some type of public key that's beaconed out from the device, and a timestamp value associated with that public key. And then the finder device is able to encrypt its location reports and upload it to the crowdsourced network. The implementation in the Blind My paper suggested pre-generating the keys, and we did not like this implementation, but essentially when the owner device and the accessory were paired, it would reach out to the crowdsourced network and pre-generate a bunch of signed keys that the device was then able to use. So when the accessory is periodically rotating these keys and the finder device receives the key, the finder device is able to encrypt with that key, but then the owner device is able to pull down that information. So even if somebody was sniffing the key, they wouldn't know the signed version of that key, so they wouldn't be able to use it. So this gets into the implementation details where, as is suggested in blind signatures, the way you generate a blinded key is you have some type of private key, public key, and then the info field, which is just some type of auxiliary information, which they recommend could be time-based information, and then that generates a blinded key. And so specifically having a blinded key prevents the crowdsourced network or that central server from tracking those keys. Next slide. And so another piece of that authentication would be that the crowdsourced network is ensuring the acceptability of the timestamp. So this means that that auxiliary information is trying to keep the signing or the request within a specific window. So we wouldn't want somebody to be able to generate future keys either, or to forge signing requests. I forget what I wanted to say on the rest of this slide. This is basically just kind of going over how blind signatures work. So I think I want to just go to the next slide. So the Finder device is going to receive the advertisement via Bluetooth. We think that it should have some type of mechanism to authenticate that the advertisement they received is a valid public key. So this is where it gets a little difficult because I'm not a cryptographer. So the Finder device is receiving a beaconed, unblinded key, but then it has to find a way to authenticate that this key exists or is valid with the crowdsourced network, but the crowdsourced network only knows about the blinded keys. So this is where I thought there was an interesting proposal by Johns Hopkins where they talked about multi-dealer secret sharing. So I think that could be an interesting way to not fully expose some of the information about these signatures, but also make sure that we authenticate at every point in the process. Eric also suggested using the HPKE seal and using that to encrypt. So that's just another encrypted protocol. Something that a cryptographer would need to help us with is, should we be working with hashes, or should we be sending out these public keys? What can we send out in the clear, because these things are beaconed over a channel that can be sniffed? So what can we beacon out from the actual devices? What can be uploaded to the network? And what preserves privacy? So yeah, these are like all very open questions, because it really isn't clear like what the perfect implementation is. Next slide. So finally, the owner device is going to query the crowdsourced network. So they should be able to retrieve the location of a paired accessory. In one of the implementations, having the public key and specifically the signed key, as well as the correct time-based auxiliary information, they should be able to pull down that report. And they should not be able to pull down reports that they do not have valid signatures for, nor they should be able to pull down reports that are outside of the specified time band. Something else that we talked about was, should we make sure that the crowdsourced network is actually rejecting Finder reports that are invalid? So instead of leaving it on the owner device to make sure that they're pulling down these authentic reports, we really shouldn't allow the crowdsourced network to store invalid reports either. Next slide. So yeah, this is kind of a big ask. So I'm a reverse engineer, not a protocol architect. I reverse engineered most of the Find My protocol and their anti-tracking framework. And I reverse engineer and jailbreak devices all the time, but I'm not a cryptographer. So definitely need some cryptographers to assist with the implementation of these solutions. So we have to make sure that we adhere to the limitations of the BLE protocol. some of the issues that we do run into is that as much as we would like to authenticate every element of the communication between the accessory and the finder device and the crowdsourced network, is that, you know, we're limited in packet size. So we can't have all of the information possible for like the largest key size or like multiple keys or all of these things, because we also have to adhere to those limitations of we only have an AirTag with a battery that lasts for, you know, a finite period of time and can't be doing all this crazy stuff. But we do want to make sure that we're authenticating the participants of the protocol while also preserving the privacy of those participants. So hopefully a scheme like blind signatures or partial blind signatures or multi-dealer secret sharing or something that one of you really smart cryptographers knows about that I do not know about could be proposed. And I
There's
think
one more.
that's it.
Some recommended reading.
Oh yeah, so these are all of the papers, I think, all of the papers that I would recommend reading that talk about reverse engineering the Find My protocol from Apple, Samsung protocol, proposed blind signature scheme for crowdsourced networking, things like that. So recommend reading those.
All right, so I'll just say that I think in terms of getting others to review, I think as gets published and becomes a working group document, people are going to want to get famous breaking this. So I think we're going to have lots of input. And I can see some people in the room whose jobs is to break things, smiling
That's
and
perfect.
chuckling in the back row. So I'm not too worried about it. We just got to get it, the thing in the group and get it going. And so to that point, I know that we had some, I guess you and Ecker were having some negotiation issues to try to get the draft published. Do we think that that's going to happen in a couple of weeks? Because I know he's off doing something else right now. So do we think we'll have a draft published that we can get cranking on, where I can do a work group call for adoption?
I think so. The current, I just merged like what I had. Since I'm new, it might be helpful to have somebody who wants to read this, because I think it's fine as a draft. I'd love to get other people's inputs. This is my first draft. I really do want people to break this. Like, that's, as a hacker, that's what I love. I want people to break this. I want people to make it better.
Like I said, I think we're not going to have that problem here.
Yeah.
But in any event, all right. So the plan really is for this, when this document comes out, we're going to do the same thing. There's not a competing proposal that's been proposed. So unless anybody wants to get to the microphone and say, like, I don't think this is a good starting point, I think we should just get to marching. Because again, it's a starting point. If we decide to do partial or full, or instead of elliptic curve, we come up with whatever, you know, that the CFRG blesses for us. We can do all that stuff. But at the end of the day, we just need to get the documents adopted and get moving. Sound like a plan? All right, I'm seeing thumbs up, no shaking heads. Thanks, Chris. All right, cool. All right, so the next thing is, thanks, Christine. All right.
Thank you, guys.
Go back to the agenda. Really is the chair slides again, where we're going to go down to insert your name now. Yeah, I fixed them, but just didn't get into data tracker, whatever. So we have this unwanted tracking algorithm document where I mistakenly thought Brent was going to do it all for us, but he said he isn't. So we're looking for volunteers that would like to write such a document. And if you would like to get famous and get involved, this is a great way to do it. I can totally help you through the process of how to press the buttons and make a draft, and you can learn all the fun tooling. But yeah, this is where we basically start to ask for help. Now, maybe the other authors will, as the other documents get more formalized, will band together and do this other part. But at the end of the day, we do have an open slot. So I guess I'll be appealing on the mail list as well for others to join in. So it's just kind of an open plea. Is there anybody sitting here that's like, oh, I really want to do this? Oh, great. We got one guy standing up. I was going the wrong way. All right. Okay. We'll work on that. All right. Thanks. Okie dokie. So now we're up to.
Sorry, Sean, could you clarify what the problem is for that document? Like, what?
It's just that we need somebody to volunteers to actually like put pen to paper.
What does the document do?
What did I even put? Can I remember what the thing was? it's defining the crowdsourcing algorithm, unwanted tracking algorithm. So it's part 3 of the, Christine jumping in.
Oh yeah, you could finish if you want to explain it first, and I was going to just say I had somebody in mind maybe.
Ooh, well, that's even better. Yeah, so it's number 10 in the architecture, wherever that is.
Yeah, so the unwanted tracking algorithm kind of like in concert with the crowdsource finding network. So let's say that somebody does have an air tag, and so we're able to prevent any, or not an air tag, but just one of these trackers. So there's some Bluetooth tracker that's legitimately on the protocol that I put into Sean's backpack because I'm a bad actor and I want to stalk him when he goes home from the conference. So that is what the unwanted tracking algorithm is essentially addressing. So this would be, legitimate items on the protocol. Technically, somebody could still use for stalking, because I could say, oh, I'm just going to buy, some type of tag and put it in someone's backpack, and then I'm going to be getting those location reports. So we would want the unwanted tracking algorithm to be what detects that device is not tracking Sean's backpack when he leaves it at the conference, like when he leaves it in the conference room, but it's I maliciously put it on him to track him and find out where he's going. So I was thinking that Alex Heinrich would be really, really good for this. I think he might be on the call. So yeah, I think Alex could be really great. He does a lot of research in this area. Maggie shared his paper earlier. So, oh yeah, thank you, Alex.
All right, well, we'll twist his arm off list. Cool. All right, so
Thanks, Sean. Can everyone hear me okay? Great. So I just have a few slides because this internet draft has some heritage and has been around for a while. So let's just jump into the next slide, please. So just a couple agenda items. I'm just gonna give a little bit of background on the heritage of document number 3, and then I'm basically gonna walk through the table of contents and describe those sections in a little bit more detail. Next, please. So this is the protocol between, document number 3 is the protocol between the accessories and the non-owner nearby devices, including the data formats. So we uploaded the internet draft to data tracker back in, gosh, a month ago, which is great. The reason I think we've got a pretty good working document already up and running is because this is based on an existing internet draft referenced here that was, I guess, published in December of 2023. It's what Apple and Google used as an initial specification for our cross-platform support for unwanted tracking that we released in the May timeframe. So lots of bits and pieces already in there that I think are really, really relevant, really helpful. We cover items 2, 4, 5, 6, 7, and 8 with a little bit of overlap between the other documents, referring to that system architecture diagram again. And again, this is not a complete internet draft, but we copied and pasted big chunks over because we think they're a great starting point. Next slide, please. Okay, so I'm just gonna walk through high-level table context quickly. So introduction and background, probably the most meaningful thing here to consider when looking at all the documents is we have a section on terminology. I see that some of the other internet drafts have similar terminology, so we'll want to reconcile that and maybe put it in a better place. In terms of the requirements section, this is the biggest section of the current internet draft. There's just a little bit on Bluetooth Low Energy because that's the primary transport we're talking about throughout this document. There's a little bit of NFC discussed too, but that's really for a small set of features. Then the next subsection is on location tracking. It talks about when you need to advertise a Bluetooth advertisement that can be used for detecting unwanted tracking. The next major subsection is the actual payload of that advertisement. There was a lot of thought put into this. So the payload contains a header that is very well defined that allows different platforms, whether it's iOS or Android or other operating systems, to reliably and easily detect that an accessory is potentially being used for unwanted tracking. And then it also allows for a payload that is proprietary to the individual companies or the finding networks that they may put in the want to put in their own stuff. I know this is up for this is hotly debated in the BOF meetings and the previous working group. So I suspect that parts of this will continue to evolve, but hopefully the header could remain the same. Then the next subsection is on the allowable Bluetooth MAC addresses. There's some, most of them are allowable based on what's in the Bluetooth specification documents, but there's some reasoning about why certain ones are allowable and why other ones are not. The next subsections on service data TLV and the network ID. The service data TLV section defines a, it's called a UUID, but it's a very short identifier that goes into the Bluetooth header that was purchased from the Bluetooth SIG so that any platform can recognize that this advertisement is for unwanted tracking detection. And then the network ID is just an allowance for different finding networks to exist and have a unique identifier for them. The next few subsections are on the near owner bit, advertising interval and connections. Near owner bit is exactly what it sounds like. It's a bit that indicates if the accessory is with its owner or not. The advertising interval is an allowable section, talks about an allowable range of advertising rates for Bluetooth advertisements. It can't be too long or things like connecting to the accessory or detecting it reliably don't work well. And then finally, there's some information on Bluetooth connections. There's a defined GATS characteristic and GATS service UIDs, which are needed to connect to the accessory. And then the next subsection is on the proprietary company payload. We talk about some of the privacy requirements that needs to uphold. Then there's the accessory information section, which is a very big section on opcodes. So all the commands and responses that can do things like play sound, serial number or identifier number lookup, querying off other information for the accessory like its make and model. Hopefully that can all be reused. There's a lot of thought that went into that part. And then the other relevant subsections are disablement identification. You have to have a way to disable an accessory if you find it to protect yourself. And then identification is a way, this is talked about in the other presentations, a way to uniquely tie an accessory either via a serial number or some other identifier back to a particular owner. And then the owner registry is something that is set up at pairing time to allow the association of that information, the serial number or identifier, and the owner information. And then and then the last four sections are pretty brief. The accessory category information section is really just a table of the category values for different types of accessories. We allow a backpack, a bicycle, and a tracker all have unique identifiers, a small enumerated type. And then the firmware update, platform support section, and the onboarding sections are basically just placeholders for new text. Great, so quick walkthrough of the outline. That's all I had. I have a set of questions. I'm hoping the audience has a set of questions. And I'm gonna get a drink of water.
Okay, all right. All right, great. All right, Christine, fire away.
Yeah, I just had a question about I was looking at the protocol, and at first I thought that it was deviating from like the advertisement requirements defined by SIG, because it seemed like it was removing the FF tag, which comes right before manufacturer specific data. But then Alex explained, I guess you guys are implementing a new BLE service rather than sending a BLE advertisement. So can you explain this change and explain how it's going to affect backwards compatibility?
I think I understood the question. I think the question was, there's discussion around advertisements and also services or connections, and what's different there, and how does it interplay with backward compatibility?
Yeah.
Yeah, so the advertisement, right, is what these accessories are doing all the time to say, here I am, whether it's for crowdsourced finding or unwanted tracking detection. I'll get to the backward compatibility part in a second. That's absolutely needed. The connections, though, are also needed. So, for example, if you detect that an accessory is traveling with you and you show an alert and you want to tap the play sound button, that requires obviously a connection to send an opcode to the accessory to have it play sound. And what I mentioned that's in the document is and these are also registered by the Bluetooth via the Bluetooth SIG, is a UUID for the GAT characteristic and the GAT service that allow you to ask the accessory, hey, do you support these particular services? If the accessory says, yes, I support those, then you can send opcodes that are valid on those services. Did that answer your question?
Oh, okay. So this service is being introduced in addition to the existing advertisement framework. Is that?
Yeah, my understanding of the way Bluetooth GAT works is that you have to have a service UUID and a characteristic UUID in order to ask the accessory, are you capable of supporting this class of things? You use those identifiers to request that. And if the accessory responds affirmatively, then you know that, hey, I could send a set of opcodes associated with those services and characteristics to tell it to do certain things.
Okay, gotcha. So the advertisements aren't going away. This is just an additional service on top of that, basically.
That's right. You need the advertisements and the services that are built upon the connections.
Okay.
Yep.
Thanks.
All right, cool. Now we got Nick.
Great.
We got plenty of time. We got 35 minutes, folks. So.
Cool.
If Maggie's comment is about the same question, they should go ahead because I have a totally separate question.
I'm sorry, Nick, I didn't catch that. Go to the next person. Okay. Maggie?
Hi, yeah. So this is something that I wanted to bring up, but I kind of wanted to wait until everyone had presented because I'm not sure where this should go yet. But one of the big things that we've talked about in our document and a little bit in some of the other documents is this idea of having support for active scanning. And it seems like that needs to involve the platform in some way. So I guess one of my first questions was, where did we come down on the topic of what we're going to require or suggest of platforms? Because I saw that you have a section, Brent, in like a to-do section about like platforms. So like maybe if we had some guidance about active scanning capabilities of platforms, it would go in document 3, but maybe it would go in the new document 2 that we haven't written yet. Yeah, you think 2?
Yeah, my thinking is the way we decomposed this last time was the unwanted tracking detection algorithm, document number 2, is all about the, what are the heuristics or policies used to detect that a AirTag or other accessory is traveling with you that you don't recognize, and when to, tell the user about that. Given that's an example of using passive scanning as you've defined it, I think you could consider expanding the scope of document 2 to include active scanning.
Okay, yeah. And so then there's some, like, there are certain things that are in this protocol right now that are hard coded in that maybe would change based on the algorithm in the passive tracking algorithm in document 2, right? Like the 30, like it has to be disconnected for 30 minutes or these kinds of things, right? So we just need to make sure that those are synced up, I think. I think that was it. I have some other minor things, but we can just talk about those offline.
All right, cool. Nick?
Yeah, I guess I was curious if you could, like, I know the section hasn't been written yet, but what do you intend for the section on platform support?
Good question. So if you read the previous internet draft, that was the one that Apple and Google provided ship support for. There's a little bit of discussion in there about what's needed. One of the things that is described in that document is if I don't ever want to see unwanted tracking alerts for my own accessories. And we have this concept of a near owner bit to say, hey, this accessory is with its owner, therefore don't show an alert even if it's traveling with you. But there's discussion in that other document about kind of a belt and suspenders approach, where my devices know the public keys that should be advertised by my accessories. Therefore, even if an accessory that I own is traveling with me, somehow its near owner bit is set to false, that I still have a way of preventing showing unwanted tracking alerts because I know the set of keys it should be advertising. There are some challenges when you expand that out to all potential parties that want to participate on the different platforms out there, whether it's Android or iOS. And we think that there may be some additional thought on how to best provide APIs to provide all different app makers and tracker makers the way to correctly prevent the showing of unwanted tracking alerts, given that set of identifiers. That's a little, a little vague intentionally because I don't know the best way to do it. And really, I think I'm just leaving this in as, hey, we should think about this. I don't know if it has to stay in the final version.
So it sounds like maybe that's, we would want to generate requirements from non-operating system vendors who are producing trackers or crowdsource networks to see what needs they have to operate these protections. So is that what would go in that section?
I think so. Yeah.
Okay. As opposed to like one thing we've also discussed here, although I'm not sure we've decided if it's in scope, is like how should we should there be requirements on operating systems about how they handle alerts for how they describe alerts to users about potential unwanted tracking?
That's a good question. I'm trying to remember in the charter if we talked about that. If it's within scope of the charter, my recommendation would probably be document number 2, but I don't recall if it's in the charter or not. Anyone else know the charter off the top of their head?
Nope. I don't see it.
I don't know if we addressed it in the charter, but Erica did bring it up. So I do think it is something important to address, and maybe it would need its own document. But yeah, I do think that is something that we should definitely, whoever's taking minutes, if you could write this down as something that we should address.
I have a general question then. When we come up with topics that are not in the charter, but we're interested in, what's the best way to manage that?
Well, usually you just stick it in a document you've already adopted, to be honest. But if there's something that's, did I say that out loud? If it's a big enough topic and it needs its own document, you can update the charter. We can always add a new document. It's not hard. It just takes a little bit of machinery to get the ISG and our AD to agree. And she's new, so she wants to learn how to press all these buttons. So we can, if we find things that we think that need to be added, we can definitely do that. Fair enough. Just not the close button, not the close button. So, yeah. Hi, Jonathan.
Hi, Jonathan Hoyland, Cloudflare. Could you say a little bit more about what you think, what we're thinking about active scanning? Because I mean, I think it would be hilarious if I could walk down the train and make everyone go beep if they have an AirTag.
Yeah, so this document number 3, I don't think needs to cover active scanning. I mean, maybe there's a part that needs to go in, but I think if you're advertising, so what's in the document today? It advertises it's an unwanted tracker. You can create a connection to pull off things like the make and model. I think that's the bits and pieces you need that if you wanted to implement active scanning on a host platform, that you would be able to present all the right information. But I wasn't intending to talk about what an operating system would need to do or policies around active scanning in this document, given it's more of the protocol between the
Yeah, I guess my question is more about like what is active scanning intended to mean, whether it's in this document or not?
Maggie, do you want to take that one? That was you defined it and talked about it earlier. I think I know.
Yeah, so let's see, what did we call it earlier? We said a search for location trackers manually initiated by a user. So I think we need to define it in more detail somewhere.
But the intended behavior is that I could, have an app on my phone that makes anyone with an AirTag near me go beep.
Well, so we have to decide what the what you would do if you did detect something, and also what kinds of circumstances under which you would, like, a thing would be detected. So, okay, so let me explain like the reason why you would want this. So the reason why you might want something like this is because, especially the way a lot of things are developed right now, is if you're relying on passive notifications, then you want to scan your environment to make sure that there's nothing around you before you go do something high risk, for example, or you're trying to leave. And so we want to have some way for people to be able to scan for those things, right? But I mean, maybe what you're suggesting is that there could be a way to abuse that, right? So we need to find a way to allow people to actually be able to scan their environment, like in a domestic violence situation. And then maybe we also have to think about ways to not allow, someone to get on the subway and beep everyone. So I think that's something that we have to figure out. But I feel pretty strongly that we need to have some ability for people to do that under certain circumstances.
Yeah, I mean, if I could just make this real, looks like Greg said that the normal protection from the beep attack is that trackers won't do it if they're in proximity of the owner, and that's correct. So in the current implementation of a quote active scanning tool, there's an app called AirGuard that you can download that was developed by TU Darmstadt, and you click manual scan on your device, and it will look for any device that is beaconing BLE, whether it's an AirTag, smart tracker from Samsung, or a tile. But if you attempt to send the request to make it beep and it's something that's paired with the owner, then it will not beep. So with an example, if I'm trying to stalk you and I put an AirTag in your backpack and I walk away, I'm out of BLE distance. If you click manual scan, it gets detected. You can send a request to make it beep and it will beep. But if I'm within BLE distance of you, like I'm stalking you and I'm in the conference room, then you try to make the AirTag beep and you cannot make it beep at this time. So yeah, I think this is an interesting use case that we should definitely look into.
Very interesting. Thank you.
Christine, you're back in the queue.
Sorry, I was just trying to
Okay.
kind of put it in real terms. I think it's helpful when we use real examples.
Okay, so we're at the same point now, unless you have questions too. All right,
I have
cool.
questions.
All right, cool.
Yeah.
Let me go
So
back to the
a
question.
few others for the audience, just to get feedback. So one of the ones was, and this was discussed, I think, in Prague and maybe last session too. And the specific question I have is, should we reuse the Bluetooth advertisement header that was published in the previous internet draft and the one that's in document number 3 right now? The value of reusing not only that specific format for the header and the UID is we would have backwards compatibility to any accessories that are supporting that previous protocol. Anyone have thoughts on that? And I realize not everyone's read the document, so it may be hard to.
To be honest, like as much as I like backwards compatibility, I also wouldn't want a bad actor to like have a really old AirTag that for some reason is not able to be detectable, or some really old device. So I think we do have to think about if we're not going to force old devices to either update to some new protocol because it's not possible for them to have some type of firmware update that has it follow the new protocol. We need to like really think long and hard and consider, like, is there a way that the backwards compatibility will be abused because somebody has some old version that is like not trackable in some way. So that's just my 2 cents on that.
Yeah, that's a good point. We did add versioning into that, the software we released, the protocol that we released to anticipate at least that aspect of it.
I mean,
And
Yeah.
yes, you're right that there are some accessories that will probably never be able to update to the newest stuff.
I mean, from a protocol design perspective, greenfield is always better. So we can always take this to the list too.
Yeah. Okay. A couple more questions.
Yeah, go ahead.
So the set of opcodes that are defined in the document for things like play sound, serial number lookup, pulling off the make and model, again, same type of question. Should we reuse those opcodes? these may end up being rhetorical questions
Oh,
at
but
this
I mean,
point.
so again, from a design perspective, right? If there's no reason to change it, I just leave them the same, right? There's no, I don't know if there's a scarcity of space or whatever, but yeah, I just.
Opcodes are pretty cheap when it comes to firmware space, memory space.
Christine?
Honestly, like my only issue with the protocol as it stands right now is the fact that the differentiation between like nearby and separated is really just that one bit. And that one bit is what enables with the current implementation, and the current implementation doesn't have authentication of those accessories. So somebody could have a tag that is always, quote, in nearby mode, and then it's not triggering the anti-tracking framework. So yeah, that's my issue with that specific opcode. But I think if we authenticated the accessories, then maybe that wouldn't be an issue. So some of these specific accessory like bits or bytes really kind of depend on like the aggregate look at like how are we leveraging crowdsourced network protocol, what are the protections that we're putting in between accessories and finding devices and owner devices, and not necessarily not saying that those other things don't matter, but like it wouldn't matter as much that this one bit is like a huge issue right now.
Yeah, that's good feedback.
Bob.
Yes, hi, Bob Hinded. So just to the previous topic about older devices, at least if I think I comment on what I think I heard said, I mean, this is the IETF. We're not the protocol police. We don't regulate what people deploy. We make voluntary protocol standards. So there is no ability here to force any old device to update. We don't actually have any ability to force new devices to do stuff. So we can make technology available that we think is better and hope that people will deploy it. But there is no ability to force any old device to run some new protocol that it may or may not be capable of doing. So I hope that is clear.
Jonathan?
Jonathan Hoyland, Cloudflare. Just to respond directly to that, given that there is a centrally controlled operating network, tracker network, if Apple decides, oh, some old tag is now bad and broken, they can just be like, bye. But they can just stop it working if they choose to.
Certainly Apple could do that, but the IETF can't make them do that.
Oh, sure.
Right. So that's saying this is a protocol, voluntary protocol standards. We can't force companies to do anything like that.
But it's not something that's impossible that it could happen, right? It's not something like, oh, we can't get rid of all these old devices because it's technically impossible. There is a central single body that could do it.
I have more. Yeah. Okay, go ahead.
But there isn't, because Apple's Find My network is not the only network out there. For example, Tile runs its own network, and there are other networks out there, and other makers of physical trackers could go and stand up additional networks. So it's not like Apple holds all the reins here.
True. All right, cool. Go ahead, got more?
Yeah, so next one is more about the structure of document number 3. So Bluetooth LE is a primary component of crowdsourcing networks today. The way I wrote this, it's kind of interwoven into the document. We could, though, instead anticipate future technologies and make this document more transport agnostic. I don't know what the next transport would be, but that is one way to consider restructuring this. people have any thoughts on that part?
I do know at the last meeting, somebody did ask what was the next protocol. We said, we'll do this one first, the next. So it's not a bad thing to be thinking about because I don't know what it is, but
Yeah.
it's something it may be coming down the pipe.
Is the question about like like a non-Bluetooth future?
Yeah, so what else is out there? There's Bluetooth long range is another protocol, which is maybe a little bit different. You know, there's other companies that have released, tried to release like pet tracking networks on like 900 megahertz or other like cellular signals. So ad hoc networks. So just trying to think, like people have tried to do it. I imagine Bluetooth won't be the only primary crowdsourcing network transport for the next N years. So should we kind of reorganize the document to be a little bit more transport agnostic?
Are there any constraints imposed by Bluetooth, I guess, that matter for, yeah, go ahead.
Yeah, I mean, the payload size is a big one. You have 37 bytes total, including the MAC address, so you don't have a lot to work with. But like all transports have constraints.
Right.
Yeah.
This is Barry Leba. My answer to the question would be yes, do reorganize it. Yes, there might be constraints that are driven by Bluetooth and they need to be in there and you can call them out, but have the transport section be separate and pluggable so that somebody could plug in another transport. We've done that in many protocols and it works pretty well.
Yeah, feels like the right thing to me. Appreciate that.
So one of the other things that I think will be coming at some point is the ultra-wideband, 15.4 type of things, because now the phones are already using that to do actually the ranging. And there is an IEEE working group or task group, the 15.4AB, that is actually working to enhance that ranging. And there's lots of things that they are actually now doing. They are moving they did used to set up the ranging in Bluetooth. And then use the ultra-wideband only to the ranging. Now they are moving this, setup from Bluetooth to ultra-wideband, narrowband, PHY in there, so they don't have to have a Bluetooth. Which means that if they are not going to be having Bluetooth, they probably aren't going to be, doing this advertisement or other things also over the ultra-wideband, so they can actually reduce the battery life a lot. So that's actually something that I don't think the current draft has anything about that yet, but I think they are moving on that direction.
Yeah, and I'm familiar with some of that movement, so thanks for the comment.
So the only thing that I would like to note Nick's comment, because I kind of tend to agree, because I'm about trying to get documents adopted. I wouldn't try to do the reorganization until after it got in the working group, because if I don't want to wait for you to do the editorial stuff. Yeah, cool. Right.
Then I guess the last one is really about, is this document ready? Is it at the right place to adopt it?
Always be closing.
Yeah.
So again, this is kind of the same as the first document. We have a document, it isn't in our draft. It's gone through the process. Having heard and what we've talked about today, does anybody think we're not headed in the right direction? All right, I'm seeing thumbs up. I will get a working group adoption call started today, like the other one, and in like 2 weeks. So get everybody read and respond, and we can get on and get the document adopted, and then we can massage it, and we can now then tell you what to do because it'll be a working group document, right? So great. And again, so thank you very much.
Cool. Thank you.
So kind of just wrapping up today, the basic plan is the document 1 and 4 and 3. We're going to start a working group call for adoption shortly. We're going to get a group of people together to start working on our number 3 and on the one that we didn't have, which is number 2. And when have I completely screwed that up? Hold on. You're right. Yeah. Okay. And then the one that we have for document number 1, when we actually get it published, we'll do the same thing. So just as soon as it lands in the repo, I'll go ahead or it lands in the data tracker, I'll go ahead and just kick the working group last call or the working group adoption off, and we'll go from there. And thank you very much for today. Thanks for all the presenters, and thank you very much, Chris, for taking notes. I don't know, Erica, do you want to add anything at the end here?
No, I think this was a fantastic conversation. I learned a lot, and I really appreciate everybody's work on this. I was taking lots of notes very quickly and learning. So thank you.
All right. Awesome. Thank you very much. Everybody have a great day. All right. Sweet.